Okay, hello, good afternoon. Nice to see you all. I'm extremely sorry. I'm supposed to grade you before, but I was planning to, but I teach three places, three community college right now, one university. So that's why I was overwhelmed because it's the end of the semester, but I find out your labs. First of all, I saw your work and I find out that this is this sign called Ohm. Let me write it down. Uh, this sign is called Ohm. This is a Greek letter OHM. This is not O. Do you understand? This is Greek letter Ohm. So most of you are going to study the engineering or application base physics, and that's why you need to know this kind of sign. And I also find that rho. This is small p, but rho p will be at font. Let me rho. I will search you. RHO rho. Rho is rho symbol. Here is the rho. Rho represents the density. Rho could be mass density, and rho could be any kind of other sign. So rho is very important. Rho is a Greek sign, Greek alphabet. From Greek alphabet, we use rho, and this sign is from Ohm. This is represent the resistance. Ohm is unit for resistance, and this is rho. I will write it little bit wrong because I am writing with the my. So it's very important, guys. Very important. It will be like that, but when you are writing, you like P, but P the what is called O on a P will be at a little bit font. So this way you will write the row sign, and most of you write P instead of row. You understand? When you are writing on the paper, you always write row as this sign. And I find out a lot of you are making mistake. And also, you most of you have done is that when you going to the engineering, then the course you are taking from me, like I'm teaching you, then when you are going to the engineering course, then the other instructor will say that you don't learn nothing. Even though it's asynchronous, that's why I get your or is get feedback of your what you are learning from your labs actually, or the exam is like that's why I give you lots of problems so that you can solve them and improve yourself. But what happens is that I find out that it will be helpful for you to get feedback from the. Cannot see what mistake you make, and no one approach me about you are not understanding or not. The earlier class where when I was taking, they approach me and I try to fix them. So try to help them also. Here is this sign is called rho, R-H-O rho, Greek alphabet sign, and this is called Ohm. You understand? This is we use lots of them. This sign is small letter alpha A. This is called alpha. This is called beta, and this is called gamma. Those are we actually use as X, Y, different kind of variable as a variable alpha, beta, gamma. So you have to think about it, and not only that, in nuclear physics, we think that alpha particle means helium particle, and also beta particle means the electron, high energy electron, and gamma is the high energy photon, means the light, high energy light. Those all are light actually, but what happens is that light energy, but this light is like those energy is different. Their energy is different. So electromagnetic wave, the all are electromagnetic wave actually, and this is the highest energy it has, gamma. This sign is called gamma, This sign is called beta. This sign is called alpha. So I have to fix your where you are making mistake. So this is the row. This is the row. This is represent the density, and it could be charge density. It could be mass density. The question will ask say C. Then if you are working in that like you are making a ship, big ship, then when you are building a ship, then what happen is that this ship you need the density of that ship, and you have to compare with the uh, uh, density of the water, and when you are comparing, then this is called specific density and specific gravity. Sorry, specific gravity. When you compare, then if it's greater than one, then it will shrink because the density of that object is lower than water, higher than water, then it will shrink. If it is equal to the density of the water, then it will float. If it's higher than water, then it will float. And if it's equal to the water, then it will stay suspended. So this is the density and this lab. And for your class, I didn't make the lab video because I know that you can search on Google and find out the help you need. But I forgot. For other community college I teach, they are mostly technical student. That's why I have to make the video for them. But for you, I know I think you are smart, but you have lots of or it's called a problem right now. I am seeing it. That's why I'm fixing. That's why I'm making this video right now. So first on this sign, are making mistake, and also you are making mistake with the unit here. Let me show you. Length unit is centimeter here, could be meter or centimeter. It's depend. If it's small, then it will be. And unit for resistance is ohm. And I find out you are making a circuit. When you are making a circuit, you are always draw like this way, guys. And this is the circuit diagram. And you never see circuit diagram with like this way. And this is the major mistake all of you made actually. And major mistake you have made, and this is the wire. That's why I'm making this video. This is the main thing that then what will happen is that when you are going back to the university, then they will say that what kind of professor teach you that he doesn't show you are making a mistake. So this way you can make it, but this is not the proper way. Proper way is always like this way. See, this is the sign for the resistance. This is the sign for the light bulb or voltage. This is the light bulb. This is not the. So let me cross this one. This is the AC voltage, and we are not making AC. AC is alternating current. DC is directional current. And we are when all the equipment is done by the DC current, because DC current and also alternating current actually change the phase constantly. That's why it is hard to work with. And most of the machine we use actually work with DC current. And also, I forgot. Can you hear me? Hello? Okay, can you hear me? Hello? Let me see. Oh, can you hear me? I think so. Okay, guys, let me, this is the circuit diagram, and we need a power supply. And the bigger line means the positive sign, smaller sign means the negative part. And current always flow from negative side to positive side. Actually, we think that the current actually flow from positive to negative. Actually, electron flow from a negative side to positive side. This side we call, let me make the, we need a switch. We can put switch this side or this side, it doesn't matter. And the wire, we need a wire to connect. And we can put the inductor or whatever you like. Inductor, that one. Let me show you. Electron flow. Values, stopwatch. And when you put the voltmeter to measure the volt, we always put voltmeter in parallelly and ammeter in series. What is parallelly and series? I will explain to you later. Right now, we don't need this one. So you are saying we don't need the values. We are saying here, this is the switch. This is the switch. This is the inductor. This is the capacitor. From the lecture, you already know this is the capacitor and this is the resistor. This is the light bulb. This is the AC voltage. Voltage or power source. We don't need it right now. This is the battery for the power supply. Right now, the light will start when you connect this here. Then light will start. If we disconnect this one, see, light will stop. So when you draw, you have to draw like this way. And why you are here is you can directly connect the light with the battery. But what happens is that why you are using resistance, because otherwise it will burn, because more power will or power or current will flow through the light bulb. This is the light bulb. See, this is the light bulb. Then this is the wire, this is the battery, and positive. This is the positive side, this is the negative side. And conventionally, that we think the current is flow from positive side to negative side. And this is the negative side, this is the positive side. I have to explain to you, otherwise you'll make mistake in future. And when you draw, I give you the grade because I did not told you. I thought you learn it earlier, but you do not. That's why from the lecture. That's why I have to fix it. Okay. This is the we think that current actually flow through from positive side to negative side, but actually a current actually nothing but flow of electron per unit time. So here electron actually flow from negative side to positive side. But when we think when scientists doesn't know about it, that electron flow of electron coming from the current is nothing but flow of electron, and that's why they make a mistake. Actually, electrons flow from negative side to positive side, but they put it other. It doesn't matter actually. Direction doesn't matter actually. It cannot change it. It couldn't change anything. So right now, when you draw a circuit, you always draw like that. When you why you I forgot the one thing that I was saying, that when why we use resistance, because we need to decrease the power, because the battery could give us more power than we need for this light bulb. If we to 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 um, to control our power of this light, then we can increase or decrease the uh, light using the resistance. If we have this one is the light, or is this called this different color. This is called color coding. From this color coding, we can measure how much resistance this resistor has. You understand? And there is some color coding for resistance. Color color bands actually. Yeah. Let me show you here. Let me show you. The first one is the this sign will be empty. That's how you understand which way you start from. There, where this side is empty, so you will start from that side. And if first one is black color, means what? If this is the digit, this is the second digit, this will be multiplier, this is the tolerance. Tolerance is nothing but what will be the percentage of error of that resistance. And this is the power, 10 to the power what? 1 times either 10. This third color represent that. Second color represent the number digit. And first one also represent the digit. And different color actually represent a different digit. Black represents 0, 0 times 1. Brown represent 1, 1, 1, 10 to the power 1. And red represent 2, 2, 2, 10 to the power 2. Orange, that's how you need to go. I will post this online. So you need to watch this video very and this what is this called? This way we draw any circuit. When you open a manual, they always show you this, all the circuit or everything, actually every kind of equipment, they always show you like that. That's why that's the important. Most of you, I think all of you done this same mistake. You post the video that diagram. It is wrong, very wrong. So I'll post this video. Sorry, and that's it. The recording. Okay. The next one, I will post another one for atom. And also I find out two things. Whatever you make a mistake, let me write it down. Unit for voltage. Voltage is nothing but the potential difference. Voltage. I actually, during my in-person class, I explained it very easy way. What is voltage? Voltage is if the water will flow from either the potential difference between the water level. If you think that the current is nothing but water, higher height to lower height, if they're connected with the pipe, so voltage is the height difference. So unit for voltage is volts. Either V, it's short form, or volt. LT, VOLT, volts. And you make mistakes. This is the mistake you made. You make this mistake that unit, no number means nothing after if the number has what is called number doesn't have any unit, then this number means nothing. So you need to put always a unit after the number. And another thing you need to know current. Hence, currents represented by I. So I is the current. So unit for current is ampere, A-M-P-E-R. Ampere. Ampere or A, whatever. If the short form, we always write when you your charger, it's ampere. You learn a lot from in future, but you are supposed to be engineer. That's why you need to know those. But nothing but amount of electron flows per unit time. But one thing you need to remember that it's a little bit higher because for DC current, electron doesn't flow. For AC current, actually electron flows. And what happens is that for DC current, electron doesn't flow. But what happens is that electron, when it moves, it gives energy to the other electron, gives energy to the other electron. That's how energy flow. And there's actually energy converting from potential energy into electrical potential energy into light energy. That's how light bulbs turn on. So to turn on any circuit, we always use you need to use switch. That's why in a circuit we always use switch. You do understand? And also the mistake and also current, voltage, and resistance. Resistance is ohm. You also make this mistake actually. Resistance is Those unit are, I am watching your lab. So I will post another video for the atomic model one, R, and unit is ohm. Ohm, this is the sign. Could be milli, the units, those ohm or OHM. Never use ohm OHM to understand what the word meaning, this sign mean. That's why we write it OHM, what will the pronunciation. That's why I'm writing it. But when you are solving the math, or even in your laptop, the laptop charger I have is 250 watt for my laptop. So it's coming from the power law, P equal to voltage time current, VI. So voltage is the volts and current is the current, ampere. So if how much voltage my laptop has, what is the amount of current my laptop can take, it's 6.5 ampere. So this is the current, and this is whatever the voltage is. I can calculate 250 if we divide 250 on the right hand side, and if we don't know the volts and times 6.5, then we can calculate the how much voltage if we divide 250 by 6.5. So that's how and even if you want to set up a air conditioner or any AC air conditioner, central air conditioner, you need it. So this kind of thing you need, but you guys make mistake, that's why. And right now, you always draw what is called diagram, circuit diagram this way. And to measure the voltage, you need to put the voltmeter like this way, parallelly with the wherever you take the volt. I can take the volt here or here. So there is a voltage drop because there is a energy loss in this resistance. That's why. And we put a resistance because in a circuit, you always, when you're making a circuit, you always need to put a resistance because otherwise it will burn your light bulb. And because the more energy in pass through that light bulb, then it can acclimate or convert into the light energy, then it will burn. I can show you if we there it is the visualization. That's why see light right now it is giving us more energy. Right now I'm adding up another. And right now if I add up another one, see, if I add another one, then it will burn. The light will burn. That's why we put the resistance to increase or decrease there is varying resistance. That's how we increase or decrease. That's how we can some of the fan, we control the fan speed by using this resistance, varying resistance. Even for the light, some light you can dim it, or we can light up using the because our power source amount of power we get is fixed. But right now it's we are changing the resistance. We cannot change the variable resistance here. This is inductor. I want to talk about the inductor is Faraday, and Faraday for capacitor, and for inductor inductor symbol. Let me see. This is the capacitor, and this is the inductor. This is different kind of sign. Let me show you. This is the inductor. This is the sign. And mine is not perfect. And resistor is like there is a path is become very difficult to. Oh, and inductor is like that. Why we need capacitor? Capacitor, we can store the energy for few seconds to increase the energy. for certain time. That's why you use capacitor, and inductor we use for, I forgot that. Here it will share this inductor curve loops. There is curve loop. One inductor symbol usually in the coil structure memory. I forgot actually. The energy in magnetic field. Oh, it's actually regulate the current. Those actually important if you design any circuit. Then you need inductor and capacitor to control the magnetic field, and because that's how we design different kind of machine. You electrical engineer, they will explain it. Don't worry about it. So those are the unit. Inductor unit is important. Henry Henry is the inductor unit. And magnetic field, I find out another thing you make mistake. Unit for magnetic field is for smaller unit, and Tesla is the bigger unit, like kilometer and meter, or centimeter and kilometer. So centimeter is like Gauss. Gauss is the first person who defined the magnetic field. With his, he actually gives the idea of the magnetic field, and then that's why to respect him, we come up with the name Gauss. There is a scientist, but we start to use Tesla because he actually designed the AC current. You find out the AC current, and AC current need from the generator. We generate the AC current, and and come from the generator, and generator works with the magnetic field. You already do this lab, and from there, uh, we can put this. From there, to respect him, we use Tesla. Tesla is bigger unit, like kilometer, and Gauss is like centimeter, smaller unit. Okay. That's it then. And there's another thing you have make mistake. Let me explain to you. All my point. Another thing, this is this one. Oh, this mm, uh, to put the resistor here to control the amount of current will flow through here. So one after another, if we put this is the light bulb. Why it's not saying the light bulb? Different kind of resistors. Okay, this is the light bulb. We need another light bulb. Right now we are adding up with the wire. This is the wire, and this is the resistance unit. Let's see. Okay. Here, this kind of orientation, we called it sometimes it rotates, that's why. Okay, this kind of orientation we call series orientation. You already know from the lecture that this kind of orientation we call it series orientation. One after another, the resistance, the light bulb and fan, whatever machine you use, they are actually nothing but resistance. And because they are actually transferring to 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 blocking the electron or resisting electron, they transferring energy into other form. Like if you see the coil, what happens is that they actually electron try to flow through shortest path, but we force them to move in a circular path in a coil. That's why electron actually transferred that to force the electron to flow through it. We actually transfer this electrical movement energy into heat energy, either heat energy for coil or light and light bulb energy. Is depend actually. So here, this is the one resistance. This is another resistance. This kind of monetization we call it series resistance, and I will show you what is called parallel. Okay, this is the one. This is the one. So this will be either this way. I'll show you. And we need another. See, here is the one resistance. Here is the another resistance. Either resistor or light bulb. It doesn't matter. This kind of orientation we call parallel because this one is parallel to this one. Actually, in physics, we draw it different way. We should. This is I'm using instead of their same thing, written the same thing. Actually, my God. Mm. When you draw it different way. I will draw a simple one. Then enter this way, and this way. And oh, I can do it there also. You don't need one. Mhm. See, this kind of orientation, we called it parallel. To make it. So when you draw any circuit, you have to draw like this way, or you are making doing drawing. So that's why you have to draw like that way. Do you understand? This is the we have to put another resistance here and what is this called? Uh, Another switch here. You don't have to right now make it simple, but you have to do it because we don't want to drain all the energy of battery or from power source. Then our current bill will be very high or electricity bill will be very high. That's why we have to put a resistance here to control how much. And we can put here instead of resistance, the light bulb or fan, or whatever you like, because light bulb and fan one kind of resistance, but it is transferring the um, electrical energy into mechanical energy or light energy, electromagnetic energy. It depends, or heat energy for the coil. So this way we draw, and this is the bell. This is the our power source or battery. It could be AC or DC. It's depend on the circuit. We are always talk about the DC circuit here in physics, but when you are going to electrical engineering, then you need it. So this way you will draw it even not only electrical engineering, all the engineering, all the topic. You always see the manual like this one. They will never show you, and you have to read the manual. They will show you like this way. They will never show you like this way. You understand? This is the battery, this is the resistance. They will looks like this way, but you need to know what terms, what term. And I think this is it. You need to study them. And I forgot one part. So that you need to watch this video. It is very important for you. And I also upload one video for the atom, how we find we get radioactivity from the atom. Okay. Mm, this is the part of it. Okay. I actually make this video for my other community college, how they find the radioactivity for their lab. So you will understand. And also the magnetic field. And magnetic field come from the movement of electron, guys. Movement of electron, proton, and electron. If you study the chemistry, there is three uh, electron number, and one of them is spin. Because of electron spin, electron actually moving, and electron is a charge particle for move from this movement of the electric charge or electron. It's generate the magnetic field. And most of the metal actually makes magnetic field because it has free electron. And why is free? It has free electron because it has the electron always try to be working pair. If they work in the pair and try to pair with the hydrogen atom, you see stability. It is unstable atom because it has number of neutron, proton, and electron supposed to be balanced. If their number is not equal to each other, or number of electron or proton is more than that, then they try to release that extra. Then it become unstable atom. And this how they release it? By alpha particle, beta particle, or gamma particle. Alpha particle is nothing but the neutron in this. That's why nuclear reaction happened because of uranium 235. 235 actually unstable atom because it has lots of neutron and proton number. When you hit this atom, unstable atom, with a high energy particle is neutron, then it will break apart and transform in the other atom. And that time, from Newton's law, E equal to mc squared, it will lose some of the mass. And this mc squared, some of the mass, and this lose of this mass, how much mass it loses, you have to put it here, then times c squared, the speed of light. C is nothing but speed of light. The mass it loses, the atom loses. If you see, E is nothing but 3 into 10 to the power 8 meter per second. So it's a very large value. Speed of light, let me. I'm speed of things. Light. No. 3 into 10 to the power 8 and E equal to mc squared. So c square means that you have to what is called take square of this value and time the even the mass is lose of the mass is very small, but what happens is that it multiply with this value square, so that it release lots of energy. That's how we get lots of energy from the nuclear reactor, more than the burning liter of oil or billions of liter of oil, more than that. But the reaction is supposed to be controlled, but it has radioactivity, and radioactivity comes from, I'll explain to that lecture actually. Okay, by then I'm making much more bigger than supposed to it. Thank you. And to see that what mistake you are making and try to warn you, or try to warn you to what will be the best course of your action. And atomic number is number of let me see. Net charge is positive or negative because there is a 2 electron more than the proton. Proton is positively charged, electron is negatively charged. And here there is 2 electron, but inside there is only 1 electron, 1 proton. So that's why it doesn't balance. Proton and electron number are supposed to balance. That's why it is not neutral atom. And I will explain actually. And mass number is 3 because mass number is nothing but if you add up neutron number and proton number, this is inside the nucleus. That's how it is the mass number. I'll explain more than on that video. I'll upload that one. Thank you. Bye.